Yes, that time we have studied about the periodic properties of a period. Properties of a period. I'll repeat that once again. I'm taking sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. That is 11, 12, 13, 14, 15, 16, 17, 18. Electronic configuration, this is the 2A1, this is 2A2, this is 2A3, and this is 2A4, and this is 2A5, and this is 2A6, and 2A7, and even like. Is it clear? So what we are studying, this is period number 3. First property which we are studying that period number is equal to number of cells. Since there are each of the cell numbers are 2, 8, 1, 3 shells, 3 shells, 3 shells, so this period number 3. Right? Going from left to right, the valence electrons in outermost orbit, it increases by 1. So valence electron increases by 1, 1, 2, 3, 4, 5, 6, 7, 8. So what is the next property? The valence electron increases by 1 and it goes on up to 8. Because we are studying the electronic configuration mentioned the valence electron cannot be more than 8. So it increases by 1 up to 8. Right? The next one. The valence of this element is 1, this is 2, this is 3, this is 4, whereas this one is 3, this is 2, this is 1, and this is 0. So valence increases by 1 up to 4 and then decreases. Valence electron increases by 1 up to 8. Valence increases by 1 up to 4 and then decreases. Then metallic character will be decreasing. We have studied that metallic character is the ability of an atom to lose electron. So going from left to right, the tendency of the element to lose electron keep on decreasing. So we say metallic character decreases. And going from left to right, the ability of the atom to gain electron keep on increasing. So we say that non-metallic character increases. Understood? The next one, size of atom. Size of atom depends on the nuclear charge. As it is moving from left to right in a shell, the nuclear charge gets increased. The nuclear charge is getting increased. Therefore, what is likely to take place? The force of attraction will keep the electrons nearer. So the size of atom decreases, and this decrease will go on up to the second last element. Till this 17 that is chlorine. So we can say that chlorine size is smaller than that of argon. Argon is why its size is smaller because argon's orbit is full. And when the orbit is full, the force of repulsion is exerted among the electrons. And that repulsion will push the electrons outwards. So we can say that these 18 group elements that are inert gases will be having larger size than that of the previous element. We cannot say that, see, sulfur size is smaller than that of chlorine because left to right we can say that nuclear charge gets increased. The attraction gets increased, so electrons will come nearer to the nucleus, therefore size will be decreasing, going on up to the second last element. And when it comes to the last element, that is the zero group element, being the orbit full, understood it? Being the orbit full, the force of repulsion exerted and by which makes the size slightly larger than that of the previous element. So one cannot say that the argon size is bigger or smaller than that of sulfur. We can say that argon size is bigger than that of fluorine. Only that which we can say. Understood? The next one, the nature of oxide. Metallic oxides are basic oxide and non-metallic oxides are acidic oxides. So going from left to right in a period, the basic nature of oxide decreases and acidic nature of oxide increases. Basic nature, metallic oxides are basic oxide, so their nature decreases and acidic nature increases. These are some of the common properties of this. Understood? Now what we are going to do is the properties of a group. I am going to take one particular group. One particular group is taken. You are supposed to learn first 20 elements. So 1, 3, 11, and 19. Electronic configuration is 1, 2, 1, 2, 8, 1, and 2, 8, 8. So this is what is we say that it is a first group. So that way we are saying about the period. Periods are the left to right columns. And period number is equal to number of shells. And this is why we say it is the first group because everything has got 1 electrons as the valence electron. So what is the first property? The group number is equal to the number of valence electron. All these elements belong to the first group. All hydrogen, lithium, sodium, potassium, all are there. Since we have to learn about first and the elements, all these elements are coming under that. Atomic number of hydrogen is 1, lithium is 3, this is 11, and potassium is 19. So you can understand the electronic configuration 21, 281, 2881. So what do we say? Groups are the vertical columns. So which group is this? This is the first group. Because group number is equal to number of valence electron. All the elements of this particular group is having one valence electron. Therefore, this is the first group. Group number is equal to number of valence electron. And how much is the valence electron? And that much is the group number. Understood it clearly? First group. The second property. So what is the first one? Is one I told you. Group number is equal to number of valence electron. Group number is equal to number of valence electron. Clear? The next one. Going from top to bottom. This is what is the group. All these elements are the same number of valence electron. Everything is having one more valence electron. Therefore, valency depends on the number of valence electron. Previous class I told you what is valency. It is the number of electrons a neutral atom loses or gains. Number of electrons a neutral atom loses or gains. And all these elements have one valence electron. So going from top to bottom, the valency remains the same. Understood it? Going from top to bottom, the valency remains the same. All these elements are having the same valency because they are all the same valence electron. Understood it? The next one. All these elements going from top to bottom, the size of atom. We are studied about the size of atom earlier. It is a total area covered by the nucleus plus the electrons. Now, when we take the case of hydrogen, it has totally one shell. Lithium has got 2 shells and potassium is having 3 shells. So what do you mean by the size? It is a total area covered by the nucleus plus the number of valence electron. Number of shells. So potassium size is larger. Why potassium size is larger? First shell containing, then 2, then 8, then 8, and then 1. So it has got 4 shells. Therefore the size is larger. Understood? And remember, as it is moving away from the nucleus, the force of attraction gets decreased. So electrons can randomly move. Are you understanding it? This is a nucleus which is positively charged, and this valence shell, one electron which is much farther away. So that will make the electron to move a little apart. So going from top to bottom in a group, the size of atom increases. Simple one reason. More the shells, more is the size of atom. Understood? The next one, metallic characters. We are studying about the properties of the elements in the period. So, in groups, metallic character is defined as the ability of an atom to lose electron. Is it clear? We are studying it earlier. An atom has to lose electron which needs energy. And that energy depends upon the force of attraction exerted by the nucleus of the valence electron. So, when it is moved from top to bottom, what is happening? The valence electrons are far away from the nucleus. The force of attraction is less, so the electron can be lost much easily. So therefore, the nucleus holds just less force of attraction to the electron, and by which the electrons can be lost easily. Therefore, what can we say that going from top to bottom, metallic character increases. And if metallic character increases, the non-metallic character decreases. What is a non-metallic character? Ability of an atom to attract electrons. And when the electrons which are to go into the valence shell is far away from the nucleus, then the nucleus exerts lesser force of attraction to keep the electron. So ability to gain electron also getting continuously decrease. So therefore, what can we say that top to bottom non-metallic character decreases. Metallic character increases, non-metallic character. Now, the next one, the nature of oxide. Is it? What is the nature of oxide? You can understand hydrogen's oxide, that is water is neutral. And then lithium oxide is basic oxide. So most basic is potassium oxide among all these 4 elements what I have written it. So going from top to bottom, the basic nature of oxide increases. Understood it? The basic nature of oxide gets increased. Hydrogen's oxide, that is water is neutral. Lithium oxide is basic. Sodium oxide and potassium oxide is the most basic. So the basic nature of oxide decreases. Understand it? Going from top to bottom, metallic character increases. Metallic oxides are basic oxides. So basic nature of oxide increases and acidic nature of oxide decreases. Understood it? Acidic nature of oxide increases. And ionization energy. What is ionization energy? The minimum energy needed to remove an electron. Minimum energy needed to remove an electron from an isolated gaseous atom. Understood it? So in this condition, potassium's valence electron is very far away from the nucleus. So nucleus exerts very less force of attraction. Nucleus exerts very less force of attraction. So by which the energy needed is very less. So potassium has got very less ionization energy than that of sodium, than that of lithium, and than that of hydrogen. Understood it? These are some of the common properties. Now, just to make you understand it easily, you study any one of the properties of period or groups and its opposite is applicable except two properties, valence electron and valency. Going from left to right in a period, valence electron increases by 1 up to 8 and valency increases by 1 up to 4 and then decreases. Whereas in a group, going from top to bottom, the valence electron remain the same, valency also remain the same. There is no change. Rest all the properties are just opposite to one another. Understood it? Now, coming back to this one, if a question is asked, an element A the element is element A is present in the third group and third period. An element A is present in the third group and third period. And what would be the nature of its oxide, or how does it combine with this one, and etc. Now, solving it, we must understand what is element. Third group means valence electron is 3. And third period means it has got 3 shells. Number of shells is a period number. So, it will be having 2, 8, and 3. So, this is the element whose electronic configuration is this. Understood it well? When we mention about the group number stands for the number of valence electron and period number stands for the number of shells. And if it is mentioned, third period means it will be having 3 shells and third group means valence electron is 3. So the electronic configuration becomes 283. And when it is 283, you can understand its valency is 3. Clear? Valency is the number of electrons and neutral atom loses or gains. This element needs 5 electrons to complete the octet or it must lose 3. So losing 3 is easy. So its valency is 3. And how does it combine with oxygen? Well, give the molecular formula of the compound A, whose valency is 3, and oxygen we know that whose valency is 2. Again, the molecular formula of the compound becomes A2O3. This is one question. Identification of element based on the group number and period number. When we know the group number and period number, we can understand the identity. Suppose like it is given an element whose atomic number is 15. Mention its group number and period number. 15. You make the electronic configuration 285. Valence electron is 5. So it is in the 15th group. Remember 1, 2, 3. Then it is 14 is added. 10 is added to that. So when it is in the 15th group, valence electron is 5, that means it is belonging to the 15th group. Third period number 285, it is in the third period. And what would be the formula of the compound when it combines with hydrogen? You can make it when that element whose valence electrons are 5, so its valency is 3 and hydrogen's valency is 1. The molecular formula, suppose like if that element is A again, then it will be the compound becomes KS3. Hydrogen has got 1 electron, it needs 1 more electron to complete it, therefore the compound becomes KS3. So once we know the position of elements in a particular in the table, we can predict everything about that element. Understood it? Now, taking the where I told you during that carbon and its compounds, silicon is a metalloid. Silicon belongs to the 14th group. Carbon in the 14th, silicon is also in the 14th group. 284. It needs 4 electrons to complete the octet, either it has to lose 4. Carbon we have studied, it shares 4 electrons, catenation, very large number of compounds. And silicon does not show the property of catenation. Reason is, Silicon has got 4 valence electrons, but the valence electrons are away from the nucleus. Then what is the chance? Silicon can lose the electron. If somebody donates electrons to silicon, silicon accepts it. In that situation, silicon behaves like a non-metal. And somebody more electronegativity comes, silicon donates the electron. Then it behaves like a metal. So in that nature, silicon shows a metalloid character. Carbon does not show. Understood it? So every element's atomic number, if you know, we can find the position of elements in the periodic table. And if position of elements in the periodic table are known, then we can understand the properties. Chemical properties can be known. Understood it? And then going from top to bottom in a group, chemical properties are only how it takes place. Whereas in this one, going from top to bottom, the physical characteristics vary. Physical one vary. The reason is, I told you earlier, hydrogen, lithium, sodium, and potassium, what happens? The melting point decreases. Top to bottom, going down in a group, the melting point decreases. Boiling point also decreases. Whereas in a period, it will be, there is no gradation, we can say that. Now, this melting point decreases when the elements in the metals group, melting point decreases, and non-metals group, melting point increases. So that's why we cannot take a general gradation of the property. You take the case of fluorine, chlorine, bromine, iodine, 17 group elements. Fluorine is a gas, bromine is liquid, iodine is solid, and astatine, that is also solid. So going from top to bottom in a metallic group, melting point decreases. Understood it? And going from top to bottom in a non-metallic group, melting point increases. Whereas chemical properties are rather the same. Clear? Now, if a question is asked, magnesium is more non-metallic than sodium, give reason. Though you know that sodium and magnesium both are metals. What I am asking, magnesium is more non-metallic than sodium. You know that they both, if a question is asked, either the elements will be present in the same group or same period. Understood it? And magnesium and sodium both belong to the same period. Sodium's electronic configuration is 281, magnesium 282. So what has happened? Going from left to right in a period, metallic character decreases. Understood it? So as far as sodium is concerned, it can lose one electron most easily, therefore it is more metallic. And when we talk about the case of the next one, that of magnesium, it has to lose 2. Losing 2 or losing 1, which is easier? Losing 1 is easier. So magnesium is less metallic than sodium. But the question is asked, non-metallic one. So you need to explain the non-metallic nature. Sodium needs 7 electrons to complete the octet, whereas magnesium needs only 6. So gaining 6 electron is more easier than gaining 7. So the one which gains electron is a non-metal. So magnesium is more non-metallic than sodium. Understood it clearly? Or if asked, potassium and sodium. Sodium is more non-metallic than potassium, though both belong to the same group. Understood it? Potassium's one valence electron is in the 4th shell, 2881, and sodium is in the 3rd shell. Right? So potassium, the nucleus exerts larger force of attraction in this case of sodium than in the case of potassium. Potassium's valence electron is away from the nucleus, so force of attraction is less. Sodium's electron is not much far away, it is somewhat like, so what will happen? Sodium's nucleus exerts more force of attraction to the electron. So sodium can hold the electron and potassium can hold the electron with so much amount of force as that of sodium. So sodium is more non-metallic than potassium. Understood it? So in this further the question is asked. Or this is a question. An element, let's say P is present in the second period and second group. What would be its atomic number? Second period means 2 shells. Second group means valence electron is 2. So the electronic configuration is 2,2. What would be the formula of its sulfide? Since its valence electron is 2, its valency is 2. Therefore, the formula of the compound will be P and S. Sulfur's valency is also 2. Understood it clearly? Most of these anions valencies you should know. What? Sulfur, oxygen, sulfate, chloride, etc., etc. Suppose like An element P is present in the P P is present in the third group and third period. What would be the formula of its chloride, sulfate, and nitrate? So, period number does not make sense. It is group number, its valence electron is 3, therefore its valency of P is 3. Understood? Sulfate is SO4, whose valency is 2. Nitrate, N number, whose valency is 1. And chloride, whose valency is 1. So, the valency of P is 3 and sulfate is SO4. So, the formula of the compound would be P2SO4 thrice. Similarly, the valency of P is 3 and nitrate is 1. The formula will be PNO3 thrice. Understood? So, this is a method of asking the question. Clear? Okay, the next property, next question what is likely to be asked is, they may give you 2-3 elements and different designs may be given on that. So for example, PQRS 4 elements are given, their atomic radius is given 0.58 or maybe 0.67, maybe 1.74 and maybe 0.008. Something else is the unit etc. will be given. And the question is, you will be asked to arrange these elements. Arrange these elements in a if they belong to a particular period, arrange them in a period. And what we have studied, going from left to right in a period, size of atom decreases. Going from left to right, the size decreases. So you get the size decrease, descending order right down, that is a method of arrangement of elements in a period. And if they belong to a particular group, arrange them in a group. And going from top to bottom in a group, what happens? Size of atom increases. So you write it ascending order and then. Clearly? Similarly, we can give you ionization energy. Some energy will be given. 5 elements will be given or 4 elements are given and will be mentioned their ionization energy. Understood it? And arrange them in a group if they belong to the same group. Arrange them in a period if they belong to the same period. And this property, ionization energy in a group decreases and in a period it increases. Understood it clearly? And size of atom in a group increases and in a period it decreases. Remember this one and then you can arrange it accordingly. They will not be asking you any reason. Understood it? And one question what I told you is the other way. The atomic number of the element will be given and ask you to find out the period number and group number. 1. Or the atomic number will be given and the period number and group number will be given and will be asked you to find out in which its atomic number. And if the period group number is given, will be asked you to find out the molecular formula of the compound that is formed. Understood it? So these are the methods of arrangement of and studying the properties. Alright, so easiest method is what I told you. The earlier method of classification you must know. That is one question. I'll revise of that one. Newland's law of octave is 8 elements arranged in the ascending order of atomic mass, then the repetition of properties take place on the 8th element. Doberian's triad means out of 3 elements which are arranged, 3 elements are arranged in the ascending order, and the middle element's atomic mass is the mean of the other 2. That is Doberian's triad. And Mendeleev's classification is the only systematic classification which are begun based on the law what is formulated. Physical and chemical properties of elements are a periodic functions of their atomic mass. All the earlier classifications were based on atomic mass because the scientists were knowing only about the size or the mass of an atom. The atoms, it was studied earlier, or it was Dalton had said the atoms are indivisible particles. And when it is indivisible, then how can you get electrons and protons? Later on, after a number of years, it was said that atoms can be divided. So that is why earlier classifications all were based on atoms. So what was the basis of earlier classification? One word answer, it is atomic mass. Understood it? You write down, suppose like state mentalist periodic law, you write physical and chemical properties of elements are a periodic functions of their atomic, that much you are returning. And instead of atomic mass, you write atomic number, no mark will be given. Similarly, modern periodic law says that the physical and chemical properties of elements are a periodic functions of their atomic number. Write everything, instead of number you write mass, no mark will be given. Understood it? I did explain what is the meaning of periodic function. Periods mean something which is repeated. So the repetition of the properties are depending on the increase in atomic mass. Like in Mendeleev's classification, it was told you the metallic character of element keep on decreasing up to certain level, and then again from the metal it is going on. That is the meaning of period. And the modern classification also had the same one. Is it clear? Left to right, sodium is a metal, magnesium is a metal, and goes on until ending up with chlorine, which is a non-metal. Understood it? So finding out the properties of an element based on its atomic number, we can understand it easily. And if you know the position of elements in the periodic table, one can even predict the properties of that element, and we can even write the molecular formula of the compound which is formed when it is going to combine with so and so. All right. These are about the properties of elements in periods and groups. And one more question you are likely to get what is going on in NCERT book is certain table will be given, periodic table might be given, some elements written here and there. Understood it? They will be mentioning about the group number and period, same method. Instead of the statement question, they will write down A, B, C, D, etc. different places and will be asking you to find out, identify the element. And when any element is to be identified, it will be coming under first 20 elements. Just beyond that, nobody will ask. So first 20 elements, you should know that. Understood? Leaving out that, period will be given and its atomic number will be given, and what is the period number of this element, what is the group number of this element, what would be its valence, and etc. So as I told you, easiest way to remember the properties is you learn any one property, either groups or periods, you learn it. And its opposite is applicable for the other one. Except two properties, valence and valence electron. Thus every properties are just opposite of the period as far as the group is concerned. Understood it? So this must be learned, periodic classification, read the book, understand the questions and everything, and any doubt or something you can ask me when you have the doubt classes. All right? That's all, and the next class onwards, I think we'll do the revision of the first chapter. So you better study that. All right? So